Welcome everybody to our webinar together with Dennis Thiele from PUK. I'm pleased to welcome you online, and let us start directly with an introduction of Dennis and myself. Dennis, please.
Yeah, thank you. Oh, wait. Okay. My name is Dennis Thiele. I'm the manager of innovation and new business from the PUK Group. We are a group. We are a group of companies. And in total, we are 3 companies together with H-Bau and Jordahl. We are based in the construction sector. In total, we serve 8 fields of applications with 10 product categories, and we have locations in we have 16 locations in the world. Yeah, here's the right slide. Thank you very much. Each company has its own focus, of course. For PUK, we are focusing on the cabin management, the underfloor systems, and as the result of the collaboration with Wiferion, the wireless charging infrastructure. Pohlcon is the holding company and is is in charge of the all the sales activities from the 3 companies as I just named.
Great, Dennis. Thank you very much. I'm going to basically rewind a little bit and introduce our today's topic. My name is Mathieu Ebert. I am in charge of international sales and pre-sales consulting at Wiferion. And I'm very pleased to host this webinar today together with Dennis from PUK. A couple of words to frame the whole, let's say, setting from Wiferion side. We're a German startup. We were founded in 2015 as a spin-off of the German research group Fraunhofer. And since 2018, we're on the market with our wireless charging technology. And since then, we've been continuously improving our product, including installation options, which is the core topic from today. And this is where we want to basically let's say, discuss today how the installation is made the best. So I'm going to start to present our technology, our company a little bit, and then later hand over to Dennis. And we're going to have a presentation of his product and his technology. And towards the end, around 16:30, we will have a chance then to have a 15-minute Q&A question. So please feel free to post your questions in the chat, as we all have done this before. And then we will have, let's say, good question for our Q&A session. So let's start with Wiferion and especially our technology and our product. So our core market, which we service today, is industrial trucks and AGVs and mobile robots. We offer wireless charging solutions for this target applications, and our core field of application is warehousing, e-commerce, and production logistics. That's where we are. Let's say that's where we're deploying today 99% of our applications. And the philosophy behind our technology, so what is driving us in principle, is the seamless integration of energy supply in logistic processes. This is what we are enabling today, and we truly believe that the integration, let's say integrating the energy supply in the logistic processes is a key factor for a good business case of electrified intralogistics today. So get rid of your offline charging process, integrate your energy supply in your actual added value process. This is what we are enabling. So as a very simple example, like on this slide, if you have a pallet mover, this pallet mover has a stop, has 2 stops basically. Somewhere it picks the pallet, somewhere it drops the pallet. And at least at those 2 points, we believe that we can charge our robot so that the robot does not need to leave the logistic process anymore. How do we realize this? We have a very lean portfolio of products. So we have a family of chargers. We have the 3 kilowatt charger. We have a 12 kilowatt charger coming up soon. And we have battery systems, and together this builds our energy solution, which we offer as a system provider for mobile robots and overall industrial electric vehicles. Why do we believe in wireless charging technology? We believe that wireless charging technology has many benefits in comparison to, let's say, other charging technologies. So our technology today is weather resistant. It's one for all for many systems. So 24 volt, 48 volt, it's the same charging technology, same product. We have a high positioning tolerance. We have a plus minus lateral displacement tolerance of 30 mm. We have a good efficiency of plus 93%, which is absolutely competitive to, let's say, standard charging systems. We have no wear and tear, no cleaning necessary, no arcing or sparks during contacting, and the whole system is a plug-and-play installation in the vehicle. We have integrated data transmission, so during charging, you get all the data, the process data from our chargers. We have an omnidirectional approach to our charging station, and our charging process starts very fast with less than 1 second from 0 to full power. And all those benefits together make our system much better than, let's say, competitive system, especially on system level. Maybe not on product level, but on system and on project level. So regarding installation, which is the focus of today, when you deploy such a technology, you have to think big, basically. You have to think not just in one single vehicle, not just in one single application. And the one for all feature allows this. So if you have a look at this very symbolic graph, on one charging station, you could potentially charge an AMR, an AGV, or even an industrial truck or a tugger train. They would all be able to use the same charging station. If you think about deploying charging infrastructure today, with the help of Wiferion and of PUK technologies, you will be able to realize this one-for-all vision, which is in the end gonna simplify your charging infrastructure. I mentioned the keyword before, omnidirectional approach. The technology we deploy today, especially the coil system, is able to be approached from four sides, from all four sides of the clock, or let's say north, south, west, and east, depending on how you want to name it. But this means you don't need to rotate your vehicle before approaching the charging station. So this gives you much more freedom in your logistic design. In summary, before we come to the more specific topics of installation, we can say that wireless or contactless charging gives you low maintenance in operations, has a high efficiency, brings a good interoperability. This means you can use it for different types of vehicles. It's fully compatible with Industry 4.0. It's an absolutely safe technology which complies with CE conformity in Europe. We are able to reduce, let's say, big current on load peaks on project level by allowing intermediate in-process charging. It's a very simple infrastructure to deploy. We're able to increase the vehicle availability. It's a technology which is well suited for lithium-ion battery technology. With a smart charging strategy, we're able to reduce the fleet size by up to 30%, which is the big cost efficiency factor. We're able to reduce the size of the batteries through systematic opportunity charging. And we have a very low threshold for opportunity charging because we're able to deploy this technology seamlessly in your process, in your project, in your factory. So now let's look on how to integrate this technology in our vehicles and in our infrastructure, which is the focus of today's webinar. On vehicle side, integrating our product is a standard, or let's say a simple mechanical job. As you can see, on the vehicle side, we have a coil, a receptor coil, which needs to be integrated somewhere in the shell of the vehicle. So it can be on the rear, on the side, or even hidden behind some kind of plastic shell. But in the end, it's a mechanical job to integrate it. On infrastructure side, you have the choice to integrate the component either on the side, or let's say in a vertical manner, or in a horizontal manner, in the floor installation. And what you see here is our on-floor installation, and we will see later how we can do this much smarter in an in-floor installation. Here we have a couple of more examples on how the systems are being installed today by some of our customers. Here we have a vertical installation, an on-floor installation, and another on-floor installation. And when we think about floor installation, we basically need to answer those four questions first before we start to select the right technology to install the right technology for installation. Are we going to have an on-floor technology installation, or do we have an in-floor installation? If we want to go on-floor because we don't want to touch the local infrastructure, we are simply, for example, renting the facilities. We're not allowed to make, we're not able to do building jobs on the floor. We would go for the on-floor installation. This is flexible, but in the end, it's not complying to the same requirements than the in-floor installation. If we want to go in-floor, then we have the solution from PUK, which we're going to present today. If we go in floor, we need to answer the second question. What is happening with the wheels of our vehicles? Because we will come to the point where we need to assess the load we're going to bring onto the coil. Do we have an AGV which is going to drive left and right of the coil? So we have little requirements to the loads on the coil. Or are we going to drive with the wheel of our AGV or industrial truck on the coil? So this is the next question we need to answer. And if we want to go in floor and we want to drive on the coil, this is going to bring us to a very hard requirement. Then the solution of PUK is perfect. Regarding safety, many people ask us, is our system dangerous? What about the magnetic field? What about the emissions, etc., etc.? So a simple answer to this is when the system is not charging, so when there's no AGV on the system, it is not dangerous because it's simply not emitting anything. It is off. Once it's charging, the AGV protects the whole system anyway. So you basically have an intrinsic safety mechanism. The whole vehicle is protecting and shielding the emitting coil. Further, our system complies to the actual conformity requirements in terms of magnetic emission. At a distance of 200 millimeters and beyond, we already are below the required thresholds of magnetic emission. And all in all, this brings us to be able to comply with the requirements of the conformity and to say this is a safe system. This was our system from Wiferion side in a nutshell. I know we could describe a lot more about the technology itself, but today we want to look at the installation. So thank you very much from my side. I just want to use the opportunity to highlight our ProMat DX participation next month. So if you are from the US, feel free to meet us on the ProMat DX. And now I'm going to hand over to Dennis to present his installation option.
Yeah, thank you very much, Matthew. When we talk about wireless charging technology, we also have to talk about the right infrastructure approach in order to take the full advantage of this great technology. And with regards to the point, when is an in-ground wireless charging spot the right approach, we have to think about the potential limitations customer may face or they may want to avoid. And here, for example, they want to avoid restricted areas around charging zones. In some areas, it's very space consuming. It's not allowed for other vehicles to drive through this restricted zones. In other situations, it's just not suitable for the facility to go with wall-mounted or on-ground systems. For example, there are already shelves at the wall, or on-ground systems are not allowed due to potential trip hazards. There's also the risk of damage and the impact of dirt and abrasion here, especially for the on-ground electronics when we look into the plug-in solutions or the sliding contact solutions. And the last very important point here is the reduction of the non-productive charging time. And I will be a bit more specific in the next slide here. You see on the left side, you see the current situations in many facilities that the AGVs actually have to leave the working cycle in order to get charged. Means a lot of time from the working cycle to the charging spot, then the time for the charging itself, and then back to the working room. And in other cases, it's like this, that the charging zone actually is not in the same building, so even more time. And other robots here are needed to compensate this off time from the robots who are in the charging process. And on the right side, you see the wireless charging spots as a part of the process. And we think here that a wireless charging infrastructure should exactly look like this. That means that every time the robot has a stop, has a pause, process related, of course, that the robot can use this off time for in-process charging. And we work on that Together with Wiferion, we developed the wireless charging protection system we named WCPS. And this basically is the protective housing unit for the charging pad, as well as the sensors, as well as the cable guiding. The full system is completely harmonized with the Etherlink system, so it's basically a plug-and-play approach here. And we focus here on the in-ground installation. And the big point is here that finally, it's possible for the customers to plan the charging processes alongside the working processes. And this is complete flush with the floor without any restrictions I just mentioned. The product combination of the Wiferion product and the PUK product now offers the opportunity to the customers to that the processes define the charging processes. And not the other way around, where eventually extra space for charging zones could be created. So let's have a look to the product setup itself. We have basically 4 components. We have here the high-end protection cover. The loading capacity is 15 kilonewton. The cover is highly permeable. The point is here to mention that the effective charging zone above the wireless charging pad from Wiferion is 50 millimeters. Our high-end protection cover is 50 millimeter thick, so there's no impact on the magnetic field here. Further, we have the housing unit where you place the charging pad in. Then we have below the leveling unit in order to bring the full charging station on the same ground level. Then we have the connection to the heavy-duty channel with also a loading capacity of 50 kilonewton. And for angle mounting situations, like you see here on the right picture, we also offer here solutions. And the full system is very easy to install. When we have a look into a project, there are basically 3 steps to do with the customer. At first, the customer has to decide where the right charging spot should be. Then the next step is the charging integration, the planning of the integration. And the last, 3rd step is actually the installation of the WCPS system, the wireless charging pad by Wiferion, and you just have to put the plug into the wall box, and then you can start with your first charging process. To sum this up at a glance here, WCPS and the Etherlink system is a true enabler for your AGVs to get charged on the job. The product saves critical space in the production and the logistic facilities. The full setup protects the technology, and as I said before, it gives you a very good degree of flexibility when you're planning your charging strategy. We prepared a little animation for you to see the full context I just mentioned here. Matej, can you maybe help me with the animation? Perfect. Thank you very much.
Great, thank you very much. Let me just open the presentation again. I see that we are already gathering a couple of interesting questions. 1 second, please. Okay, so I have a couple of questions for Dennis, which I prepared to understand his solution much better. So Dennis, please let us know, how does the whole project management, or let's say, how is the workflow from idea to fully installed PUK solution?
Yeah, the point is here that PUK is covering the full infrastructure side, means everything without the electronic from Wiferion. So we are doing the consulting for the installation, for the product itself, but not for the Wiferion product. So the customer is getting 2 packages on site, and we are also helping with the installation. In Germany, we offer this as a service, and for example, for companies in the US, we are happy to train the subcontractors. The company who's interested in this is bringing to us.
Okay, so in all, the wireless charging system is delivered by Wiferion, and the protection system and the installation is offered by PUK directly. That's how we serve the market today. Okay. Is there a chance that, so now we talked about basically PUK doing the whole installation. Is there also a chance that the customer just buys component from you and does the installation himself?
Yes, of course, this is possible. We strongly recommend to do the integration, so the groundwork, to hire a professional company who's already experienced in groundwork. But the installation can be done by the company itself. It's basically a plug and play, or plug and screw approach here. When you go on our microsite, you can see the manual. It's very easy to understand, and yes, the answer is simply yes.
Okay, so the customer has the option to either have PUK do it or do it himself. And today we see that the AMR, or let's say the HV market, is growing really rapidly. So how fast would you be able to scale this solution, let's say on German, European, or global level?
Yeah, so on the European level, we are able to deliver within 4 weeks. So I would say between 3 and 4 weeks. Depends how much time we had in advance to check the project. It's very important for us to see the drawings of the site at first, then to see or review the documents if there's anything in the ground which was not known yet, for example, a steel reinforcement or floor heating. But then after the order is placed, we are able to deliver 3 to 4 weeks.
Okay, great. Okay, so there's a question from Dinesh, sorry for pronouncing maybe wrong, but which are the applications you're focusing, and how's the market response? So I can tell you that one of the core bottlenecks we had with our system without such a protection until now was if you are in an operation site with basically mixed fleets. So if you are in a site where you have HVs running and, for example, industrial trucks, customers didn't want to have our system installed in such an area where they had to basically block a space for industrial trucks. So the big motivation to have such a system is that you simply can roll it out in areas where you have mixed fleets. This is the main motivation. The response was pretty good from the day on where we were able to offer such a solution, because the installation was most of the time the bottleneck to really deploying our technology. On the other hand, we don't have such a big track record now. We are testing the market together with PUK, and I guess then in probably half a year we will be able to give much more insight on how the system is accepted. So we see a demand, we see a benefit, and we have already realized one concrete project. How much will come, we will see. Okay, so a couple of questions which came before. So the call about the efficiency, this is a question which comes very often. 93% efficiency is AC to DC battery input. So it's not taking into consideration the battery efficiency. It's taking into consideration the whole, let's say, AC to DC charging track. And this is absolutely comparable to let's say, state-of-the-art cable-bound chargers. The next question is 30 mm distance. So the distance between the coils per definition is 40 mm, but we have an area of around 15 mm, which is not usable because the coils need to have a certain distance. And this is the layer, this is the distance basically which PUK is using to introduce its protective layer. So the effective remaining distance from ground to vehicle or from ground to coil is 30 mm. Next question, 40 volts maximum possible charge. Today, yes, our 3 kilowatt system does 24 and 48 volt systems, so it goes up to 60 volts for the end of charge voltage of lithium ion batteries. The upcoming system, the 12 kilowatt system, which is going to come towards the end of the year, is up to 120 volts. So next question, maximum load 50 kilonewton. Dennis, that's one for you.
Yeah, 50 kilo means 1.5 tons. Our system is steam tested with a stamp with around 13 square meter distance. And yeah, so what's the question again? The maximum load, yeah, I just said 15 kilonewton.
Can you comment on the codes or DIN norms you certified the system to?
Yes. The system is certified according to the norm 508.522. So it's basically the norm for tracking system for electrical installations.
Okay, I guess this is something you need to discuss offline with Dennis if you want to dig deeper into it.
Yeah.
I'm just gonna. I'm getting a lot of questions, so I'm just gonna look at some of them. So. Next question is, can the inflow installation withstand a forklift, wheel drive, over? That's the, let's say, that's the $100 question.
Yeah.
The core criteria is what is the width of the wheels,
right.
what's the weight on this specific wheel, and what's the material made of. So what, let's say, surface is really pressing on the coil. So in principle, you could say yes and no. That's why we talk in kilonewton and not in kilogram.
Yeah.
So maybe we have to say, Dennis, for specific cases, you need to shoot us a request describing your application. So
yeah,
like
showing us the wheel. Yeah.
The wheel, exactly, diameter, width of the wheel, and material, and load on the specific wheel, and then we can say yes or no.
Right. Yeah.
Okay, does the efficiency change if you increase the distance? Well, that's a tricky question. The efficiency increases slightly, but let's say it's neglectable. The more important answer to this is we guarantee 3 kilowatt of power at all time within our tolerance area. So if you are at 20, 30, 40 mm distance, you will always get 3 kilowatt. Our stationary side is simply going to overcompensate some, let's say, increasing losses. You buy 3 kilowatt, you get 3 kilowatts. That's the point. Okay. Don is asking, most warehouse and manufacturing facilities have multiple applications such as AGV pallet movers, tuggers, or lifts. They can also come in different voltages. Yep, that's correct. So today our system can cover 24, 36, and 48 volts. That's the 3 kilowatt system, and that's what makes 3 kilowatt make sense in this voltage range. And with this voltage range, we believe that you can already cover quite a large fraction of the fleet. So if you think about our all-for-one approach, this 24, 36, 48 would already cover, let's say, typical warehousing vehicles. It would not be able to cover like heavy trucks, which take 80 volt, 90 volt, 120 volt of end of charge voltage. Okay. Next questions. Will the PUK system be available for EtaLink 12,000? Good question.
Not yet.
Not yet, exactly. I think we're thinking about it. It's a bit of a matter of also the market response, the demand. If you want to have it for 12 kilowatts, or if you want to have 12 kilowatt charging, let us know. And we will be able to give you an answer when it's going to be possible. Next question. Do you specify the max XYZ tolerance to achieve the 93%? Yes, indirectly we do. In the end, we have diagrams which we share with customers, in which, let's say, in principle, it's a three-dimensional sphere we're talking about, in which position you have what efficiency. But here again, the efficiency is not the decisive point. For most of the customers, actually keeping the full charge power is more important. Next question. Somebody's asking to translate 32 kilonewton on 2,700 square millimeter. I suggest this dialogue is going to be moved,
write me an email
offline.
we will discuss this.
Exactly. Next question. This is an interesting question. Dennis, that's for you. If we're interested in PUK products for one of our projects, should we talk to Wiferion or directly with PUK?
Yeah, that's the point we just discussed. If there are questions regarding the electronics, you have to speak with, for example, with Mathieu. And if there are integrated questions, for example, then we are the right contact person, like PUK.
So in principle, from our experience, deploying wireless charging technology is, of course, a matter of installation, but also a matter of many other parameters. And I suggest to discuss your project first on, let's say, electric level. Is the use case good for wireless charging? Will you be able to cover your energy need, etc.? And once we find out that our technology would suit your application, you can start discussing with PUK, let's say in parallel, the installation topics. In principle, I know you cannot separate those two topics from each other, but we need to move on step by step. Next question. Is the charge rate affected by temperature? Well, our charging system has a certain maximum, let's say, operating temperature specification. And this is quite a wide specification, so we rarely hit the boundaries of it. But in principle, we also have an automatic derating. So if in any case you would reach some overheating in the charging system, our system would slowly decrease the charging current, aka the power, to basically stay within the specs. It wouldn't abruptly cut off. So I hope this is answering the question more or less. Next question. What is the communication option available to integrate the charger with HV control system? So in principle, our charger has a CAN bus interface on the station and on the mobile side, and you are able to pull data from this interface, and you're also able to remote control the charger via this CAN interface. Next question. For above ground charging, have you found that robots need to adjust their programming to account for above ground grade? In other words, for robots that are not able to use ramps, would they be able to use above ground solution? I am not 100% sure what this question means. This is David. Maybe we need to discuss this offline. I'm sorry for that. Okay, next question. Any EMC interference expected between AGV electronics, etc.? No, luckily not. If we would bring out a system on the market which would affect the electronics of AGV's operation, we would have failed somehow. So in principle, the question is absolutely valid, and we recommend every customer to run, let's say, thorough tests if there are any interferences. But from our internal testing and from the certification perspective, so this is concerning EMC emission codes, we comply to the requirements. And I always say you can position a PLC right behind our coil. It's shielded well enough. It will not affect your PLC. So next question. Franz Eberhard is asking, what about metal, dirt, or chips on the floor? Well, good question, Dennis. What happens if we have metal on your protecting system?
So
during charging. During charging.
Our protective cover has a fire protection class. It's B1. The smoke class is S1. So the result, it's nothing. It will not be a burn or a fire there.
Yes, I mean, maybe we can complement this a little bit. So of course, the risk of having metal objects during the charging plates, during charging, is a risk which we of course handled thoroughly. And the PUK solution is designed in such a way that it first prevents metal parts from burning into the coil, which would give an electrical hazard. They prevent it due to the glass layer. But additionally to that, the cover plate is made out of special flame retardant material and fume retardant material. So it wouldn't even smoke, if I got it right, Dennis.
Yeah, right. The smoke class is S1, yeah.
Exactly. So you would have probably a little brownish or let's say dark blue burn-in spot. So you would see that there's something happened, but you wouldn't affect your process.
Nothing more, right?
Exactly. And this is the strategy we are following. We are basically delivering a fully safe system for safe operation. Okay.
Actually, what's exactly the maximum cable length you're offering?
Yes. So today, the standard cable length is 3 meters from the stationary electronics to the coil. But meanwhile, we are able to deliver on request cables of up to 10 meters. So if we really want to implement solutions like you have seen in your video, where the charging spot is more or less in the center of a warehouse, you have a 10-meter radius to install your wall box. That's the state of the art today. Exactly. Okay, time is really running. I'm just looking if we have more questions. We have one maybe pre-last question from Horst Wienecke. Will water at cleaning on the floor affect the charging? So water doesn't affect our coils. Our coils are IP67 in principle. But what does water do with the casing, with the PUK casing?
We have a protection level of IP65. So there's no chance that water is running into the cable channel or in the protection housing unit.
So the housing and the channel is IP65 already and is then, let's say, more or less sealed so that a water scrubber or something can drive over easily. It's sealed. Okay.
Yeah, right.
Okay. Well, we've reached the end of our webinar from the time-wise. I encourage you to reach out to us from Wiferion if you want to discuss your applications in more detail. I encourage you to visit the website of PUK, the microsite about the PUK installation system. Reach out to Dennis to discuss your projects or let's say your requirements. And the US visitors from today, I'm looking forward to see you on the ProMat DX, let's say online exhibition, and to all the other visitors from today, looking forward to meet you on our next webinar. I don't know when it's going to be, but it's going to be soon, about, let's say, more thrilling topics about wireless charging. Thank you very much, everybody. Thank you, Dennis.
Thank you.
Goodbye, everybody.
Bye-bye.